How are you, learner? Welcome to our physics lesson, Manifested e-learning platform. My name is Purity Anzelimo, and we continue with physics. And in our lesson today, we now move to book 2, a topic in form 2, that is waves. We are referring to it as waves 1 because again in book 3, we'll be looking at waves and we'll call it waves 2. So it is very key that you first start by understanding waves 1 for you to be able to read and understand waves 2. So our topic is waves 1. It's a very interesting topic, very interesting, as you'll see when you follow through, and you'll be able to answer so many questions from this waves 1 if only you follow keenly. Now, you first heard of waves in book 1 in the branches of physics. In the branches of physics, one of the branch that we talk about in physics is what we called waves. So waves is a branch of physics. Do you remember what's a wave? It's a branch of physics. Yes. We say that a wave is simply, or waves as a branch of physics, it simply refers to the propagation of energy through space. We'll come to that. We'll define waves again as we proceed. So waves 1 is our topic, and we have some objectives that you should have achieved by the end of the topic. So by the end of the topic, you as the learner, you should be able to do the following. As a learner, you should be able to do the following. Number 1, since we'll come to the classification of waves, we'll be classifying waves in different types. So by the end of the topic, you should be able to explain the various types of waves, giving examples. So that is very key. Number 2, you should be able to state and explain. You can start with stating and explaining the characteristics of waves. The characteristics of waves. We'll be able to look at the characteristics of not just a wave but wave motion. State and explain the characteristics of wave motion. This is a motion now. For the characteristics of waves and the properties, we'll look at it in book 3. But in book 2, we'll be able to look at the characteristics of wave motion. That is number 2. Then number 3, by the end of the topic, you should be able to explain the terms associated with waves. There are terms that we are going to state and explain. An example of a term is a frequency. We'll be able to know what is frequency, what is wavelength, what is periodic time, what is amplitude. Those are the terms that are associated with waves. So number 4, you should also be in a position to explain the phase and the phase difference. So explain. Then number 5, by the end of the topic, you should be able to derive and apply the wave equation. Should be able to derive and apply. Should be able to derive and apply the wave equation. And finally, in this topic, you should be in a position to solve numerical questions. So these questions will be relating on what we have just mentioned, on the terms associated with waves, on the phase and the phase difference. So you should be able to solve the numerical questions. So that is the content for this topic, because in this topic the first thing that we are going to look at is the classification of waves. We have seen that you should be able to explain various types of waves. So we have classification of waves here. Then we have characteristics of wave motion, whereby you'll be able to tell when a complete oscillation is over. Then in number 3, you should also be in a position to explain the terms associated with waves. So in this, we are going to look at terms associated with waves. We'll explain each one of them at a time. Then number 4, we look at phase and phase difference, and we'll be able to draw various waves. Various waves, for example, which have the same amplitude but different frequency, and so on. Then number 5, we are saying that you should be able to derive and apply the wave equation. So in this, we are going to look at the wave equation that is on the relationship between the speed of the wave, the frequency, and also the wavelength. And finally, you should be in a position to solve the numerical questions. Now, our topic, waves. Now, have you ever encountered a wave in your day-to-day life? I want to start by giving you a very good example. As I talk now, you are able to hear. So this sound is able to get to where you are. For example, when you are seated in a class and the teacher is talking, you are able to get what the teacher is saying due to what we are calling waves. So that sound is a wave. It is able to move from where the teacher is by the vibration of particles to where you are seated. So that's a very good example of a wave. When you are using your remote, maybe you are controlling a television. When you are using that remote, it is by waves that it's able to work. Again, at your home, when you are busy just listening to a radio, yeah, the producer or whoever is talking is not near the radio, but is some distance away. So one use of the waves is that it is able to transfer information over long distances, because it is as a result of waves that you are able to hear that person in that radio station some distance or some many kilometers away from where you are. Again, have you ever taken a stone, let's say a stone, and then you throw it in a pool of water, let's say a pond? What do you observe? You'll find that there will be a set of ripples, because when you throw the stone in the water it becomes disturbed, and when it is disturbed, then it is able now to set some concentric sets like this. When you have a pool and you throw, let's say, a stone at this point, you usually find that we have some ripples which are set in that pool of water. These are what we are calling waves. So when you talk of waves, it's a very easy topic, and as we are saying, we encounter waves in our day-to-day lives. So we'll start with an introduction of the topic before we look at the classification of waves. So we look at some bit of introduction. Introduction of waves. And we can start by looking at some uses of waves in our day-to-day lives. And we are saying, number 1, it can carry information. Carry information over long distances. And a good example, we have the radio waves. So we have it. We have the waves, because we're saying that in the study of waves, we are dealing with the propagation of energy through space. So we can also talk of the remote control systems. remote control systems. That is another use. Also in communication. In communication, that is the sound waves. So you are in a position to hear what someone next to you is telling you because of the vibration of the particles. So when the sound is produced, it is able to vibrate and get to where the other person is. So those are some of the uses. Those are some of the uses of waves. And we need to note that NB, I would like you to note that waves transfer energy. They transfer energy. Waves transfer energy. And that's why when we talk of waves like the sea waves or the tidal waves, they are able to do work because they transfer energy. Remember, energy is the ability to do work. And that's why you find that, for example, the waves in the sea, they are able to rotate turbines, which in result, they are able to generate electricity. So we are saying that waves transfer energy because we defined a wave as a branch of physics and saying that it simply refers to the propagation of energy through space. So that is key. Then it involves periodic, repetitive movement. Involves, like for example, when you use a rope and you want to produce some waves and you move it on one side, you'll find that there'll be, that's what we are calling the waves. The rope moving up, down, like this. So we have the rope having such a movement. So we are saying that it involves a periodic repetitive movement. So you can see how the movement repeats itself periodically. So we are going to look at that as we continue. So this is very key, that waves transfer energy and they also involve a periodic repetitive movement. So we want now to move ahead and define a wave. So we look at what is a wave. And then we'll go to the classification of waves. So what is a wave? Now, when we talk of a wave, we can give several definitions for a wave. One, we can say that it is the transmission of disturbance. So we can say a wave simply refers to transmission. It is the transmission of a disturbance. That is what we simply refer to as transmission of a disturbance. And we are saying that as a branch of physics, it refers to the propagation of energy through space. So that's simply what we are referring to as a wave. And as we have seen here, a wave carries energy. And we are saying that there is no net movement of the particles. So you need to note that NP. So waves carry energy without the net movement of the particles. That is very key. That here we do not have the net movement of particles, but we are saying that they will carry energy along with them. So that is on waves. That is the definition of a wave. And now we want to move ahead and look at the classification of waves. So classification of waves. So in classification of waves, we have two major categories of waves. Namely, number one, we have what we call the electromagnetic waves. And number two, we have what we refer to as mechanical waves. So that is the large category of waves. We have electromagnetic waves and we also have the mechanical waves. So we are going to discuss each on its own. We define electromagnetic waves and we'll also be able to define mechanical waves, giving examples. So we can start with the electromagnetic waves. What are electromagnetic waves? Now, when we talk about electromagnetic waves, these are waves whose transmission does not require a material medium. Or we can say they are waves which do not require a material medium for their transmission. So we first define it that way. So these are waves. So electromagnetic waves are waves which do not require a material medium for their transmission. When we talk of a material medium, we simply mean it can either be a liquid, a gas, or even a solid. So they do not require a material medium for their transmission, meaning that they can be transmitted through a vacuum. They can be transmitted through a vacuum. So we can give examples of these electromagnetic waves. Examples, inchi. A very good example is what we call the light waves. We also have the X-rays, the radio waves. We also have the microwaves. We also have the radiant heat. We also have the gamma rays. All these are examples of electromagnetic waves. The light waves, the X-rays, the radio waves, the microwaves, the radiant heat, the gamma rays. We can also add the infrared radiation. Some of these you'll learn them more in book 4. There is a topic by the name electromagnetic spectrum in book 4, where you learn about these electromagnetic waves. So for now, you need just to know stating them: light waves, X-rays, the radio waves, the microwaves, the radiant heat, gamma rays, infrared radiation. All those are examples of electromagnetic waves. They do not require a material medium for them to be transmitted. And I would like you to note the following, of which we are going to discuss later in our further division of waves. I would like you to note that all electromagnetic waves are transverse in nature. We'll know what we mean by transverse, but you need just to know that all electromagnetic waves are transverse in nature. And we'll come to this, we'll know what we mean by transverse waves. So all electromagnetic waves are transverse in nature. So that is on electromagnetic waves. So we want to move on to the other category of waves, which we are calling the mechanical waves. So we look at mechanical waves. Now I'm sure you must be guessing what are mechanical waves now that we have looked at electromagnetic waves. Now for mechanical waves, they will require a material medium for their transmission. There must be a material medium, either a liquid, a gas, or a solid for them to be transmitted. So mechanical waves, they are waves that require a material medium for their transmission. And a very good example of a mechanical wave is the sound waves. The sound waves. Now, a topic before waves 1 in book 2 is sound. You realize that for sound to be transmitted, there must be a medium, either a liquid, a gas, or a solid. We think that sound cannot be transmitted through a vacuum. There must be vibration of particles, because for the mechanical waves, it is affected by the vibration of particles. So we can give examples. A very good example is the sound wave. Then the other one is the water waves. It's also another example of a mechanical wave. And therefore we can define mechanical wave. We have defined, so we can continue and say that it is affected for the transmission is affected by the vibration of particles. The transmission is affected by the vibration of particles, and therefore there must be a medium. So examples, e.g. we are talking of the sound waves, and we also have the water waves. Those are examples of mechanical waves. Now I would like you to note, we have said for the EM, we call them the EM or the electromagnetic waves. So the EM waves, we have seen that all of them are transverse in nature. What about the mechanical waves? Now for the mechanical waves, they can either be transverse or longitudinal in nature. So for the mechanical waves, they can either be transverse or longitudinal. So that brings us to another type of waves which we are calling longitudinal waves. So we'll be able to know what are transverse waves and what are longitudinal waves. So for the mechanical waves, they can either be transverse or even longitudinal. But for the EM waves, they are only transverse in nature. So that is generally the classification of waves. We are going to continue further and in further division of the waves. So in our next lesson, we'll now continue and we'll divine, or we are going to classify waves further. So we are going to say that further the waves are also classified as follows. So we are going to look at the transverse waves, and we'll also look at the longitudinal waves. We'll know what are transverse waves, and we'll also be able to know what are longitudinal waves. So that is all for this lesson. So we have been able to know what is a wave, and we have seen that a wave is a transmission of disturbance, and as a branch of physics, it deals with the propagation of energy through space. Then we are also saying that waves are very important in our day-to-day lives, and one very good example of a use of the waves is in communication. That is the sound wave, very useful in communication. And we also have many others. We have also seen that waves carry energy along with them. And that's why we have been able to see that some of the waves, like the sea waves, can be used in the running of the or rotating of the turbines. Because if they carry energy, then it means that they have the ability to do work. Then we have also been in a position to classify waves in two broad categories. One, the electromagnetic waves, and two, the mechanical waves. So you should be able to define what are electromagnetic waves, what are mechanical waves, giving examples. And finally, we have been able to further divide the waves into other categories, that is transverse waves and longitudinal waves. So during our next lesson, we'll discuss the two types of waves. So I'd like to leave you with a question. Having defined EM waves and mechanical waves, you should now give two differences between the electromagnetic waves and the mechanical waves. So follow us also during our next lesson as we discuss transverse and longitudinal waves. Thank you.